All right, let's just dive right into this explainer and, discover how to defeat the coder's ultimate villain: tedious, repetitive work. Seriously, if you've ever found yourself copy-pasting the exact same line of code over and over again, you are absolutely in the right place. Today, we're mastering Python loops, and honestly, they're arguably one of the most powerful concepts in programming. We're going to see exactly how loops let you essentially command your computer to do all the heavy lifting for you. It's like magic, transforming hours of manual typing into literally milliseconds of computation.
So here's our quick roadmap for today's journey into automation. We'll quickly cover why we actually need loops, then we'll master the for loop, understand the while loop, get into controlling and nesting them, and wrap up with some common mistakes and real-world applications. Okay, kicking things off with section 1, why we need loops in the first place, and that huge automation advantage they bring to the table. Imagine you just want to print the word hello 5 times. Now, you could manually write out that print statement 5 times, right? And hey, that works perfectly fine for super small tasks. But imagine you need to print numbers from 1 to 100, or maybe display 1,000 names from a database, or process thousands of student records. Writing separate individual statements for each of those? I mean, that's practically impossible, or at least a total nightmare. Instead, a simple 2-line loop does the exact same thing, the whole shebang, in a fraction of a second. So, the absolutely crucial point here is that by using loops, you're instantly empowering your code to do the repetitive grunt work for you. You're saving your own precious time, and you're drastically reducing code duplication. Basically, it just makes your programs cleaner, faster, and, well, way more efficient. Moving right along to section 2, mastering the for loop, specifically for when we're dealing with known quantities. So, what is it? A for loop simply repeats a block of code a known number of times. And the real beauty of the Python for loop is how incredibly efficient it is. Why? Because Python automatically handles updating the loop variable for you, right there in the background with every single iteration. You don't even have to manually tell it to move on to the next item. It just kind of knows. Now, to truly master for loops, you absolutely have to understand the range function, because trust me, you're going to use it constantly. If you just give it a stop number, like, say, range 5, it generates 0, 1, 2, 3, 4. Notice how it stops just before the 5. You can also specify a start and a stop number if you want. But the real magic happens when you add a step value as a third parameter. This is what gives you that fine-tuned control to count by 2s, maybe by 10s, or even count backwards like a literal rocket launch. You are completely in the driver's seat here. But hey, we aren't just limited to numbers. We can actually iterate directly through a string. For instance, looping through the word Python will literally output P, then Y, then T, and so on, going character by character. We can also loop through lists, like a list of apples and bananas. And honestly, looping through a list of data, that's a technique you will use all the time to process information item by item in the real world. Now that brings up a really interesting question. We know how to loop a specific number of times using for and range, or how to loop through a list that we already know the size of, but what if we only want to loop until a certain condition is met? Like, what if you're waiting for a user to type in the correct password? You have no idea if they'll get it right on the first try or maybe the 5th try, right? Well, that brings us perfectly to section 3, understanding the while loop and conditional repetition. The definition of a while loop is pretty straightforward. It's simply a loop that runs continuously as long as a specified condition remains true. Think of it like this. The loop evaluates the condition right at the start, essentially asking, hey, is this still true? If the answer is yes, boom, it runs the code block. Then it loops back up to the top and asks again. And it's going to keep running that code over and over until the answer finally becomes false. But okay, you have to be very, very careful here. Because a while loop runs based on a condition, if you forget to include a way for that condition to eventually become false, well, your program's going to get stuck in an endless cycle. We call this an infinite loop. And it will happily run forever until it eats up literally all your memory and your computer just crashes. So pro tip, always, always provide a stopping condition. All right, moving to section 4, controlling and nesting. This is where we really hand over at the steering wheel. First up is the concept of a nested loop. Now, this is exactly what it sounds like, a loop placed entirely inside another loop. Think of a standard clock, right? For every one time the hour hand moves, the minute hand has to complete a full 60-step loop of its own. It's a great analogy, actually, and it brilliantly illustrates how complex outputs are built. Whether you're generating data tables, building matrices for math, or doing pattern printing, which, by the way, is a massively common coding interview topic,
You're going to be using nested loops to build those structures layer by layer. Now, to truly take control of these loops, you have 3 special statements in your toolkit. First, break. It acts just like an emergency brake. It immediately stops the loop completely and exits. Then you have continue. That one is more like hitting skip on a music playlist. It skips the rest of the current iteration and jumps right back up to the top of the loop for the next round. Finally, we have pass. And pass does exactly nothing. Seriously. It simply acts as a placeholder for when you're mapping out your code structure but just aren't quite ready to write the actual logic yet. To see how all this comes together, let's imagine a quick practice program. When you start combining loops and math, you can build some really helpful tools, like an automated multiplication table generator. So the outer loop might take the user's input, let's say the number 2. Then the inner, nested loop counts from 1 to 10, doing the actual multiplication and printing the output at each step. Honestly, it's just a fantastic way to visualize how loops process data iteratively. And that brings us to our final part, Section 5, Mistakes and Real-World Applications. Let's look at the traps and the triumphs. I want you to treat these 3 common beginner mistakes like literal hazards on a road trip. Okay, mistake number 1, forgetting to update your while loop variables. As we talked about, that causes those dreaded infinite loops. Mistake number 2, and this one is huge, using wrong indentation. Remember, Python strictly requires proper indentation to know what code is actually inside your loop. If it's off, it'll crash. And mistake number 3, confusing break and continue. Definitely memorize their different behaviors so you don't accidentally kill a loop entirely when you really only meant to skip a single item. Now, if you're sitting there wondering where you'll actually use this stuff in the real world, well, the short answer is everywhere. Seriously, ATM systems use loops to verify your PIN or to count out your bills. Your mobile apps use them to continuously load your news feeds. Even video games rely on a massive, overarching game loop that runs continuously just to render the graphics on your screen. From machine learning models to processing giant databases, almost every single software application in existence relies on these exact loop concepts to function. So, to wrap up our explainer for today, loops are arguably the most fundamental, important concept in programming. Why? Because they completely take the limits off of what you can build. They take hours of tedious manual work and transform it into just milliseconds of incredibly efficient computation. At the end of the day, programming is fundamentally about problem solving. So I'll leave you with this question. What repetitive task in your own life, maybe at your job or just on your computer, could you automate with just a few lines of Python today? Keep practicing those for and while loops, have fun with them, and I look forward to exploring Python strings with you in our next explainer.